So this was a pop quiz 3, which was related to light topic. Figure 6.2 shows a ray of a green light is there, and you have to draw the path to show the blue light. So we have violet, indigo, blue, green, yellow, orange, and red. The violet is having the highest frequency, so it bends the most, and red is having the shortest frequency, so it bends the least. So if this is representing a green line, the green light, so we have a blue. So blue, when we compare the blue light with green light, when we compare them, blue is having a higher frequency than the green. So blue is having a higher frequency than green. So blue should bend more than green. So how we complete a path? So the moment it enter, it will bend, like it is spread from the green and then further spread. So this is a path which you have to draw. It shows that bending of a blue is more than. So we have to draw the path of a blue light through and out of the prism. So this should be the path of a blue light which you should draw. Is it clear, this one? Green is not passing straight. As you can see, this is a green light. First, moving from air to glass, like this was a green light. When we draw the normal, it will bend towards the normal. Like this is a normal. As the speed of a light will decrease, so it will bend towards the normal. So green will bend first towards the normal, and moving from glass to air, normal is always perpendicular. So moving from glass to air, like this is the green light is in glass and moving in the air, it will bend away from the normal. So this is a path of a green light is given to you. The question is, if the blue light entered the same path, you have to complete the path for blue, because blue is having a higher frequency than green. So blue should have a greater change in speed, so it will bend more than green. And then further bend away from the normal more than green. So that's how you complete a path for a blue light. How much do we bend? That is, it's not by calculation. It should appear that it is bending towards the normal, not as any specific value. Just you have to show that the blue is bending more than green. That's it. The next question is related to a convex lens. Figure 6.1 shows a converging lens, and the object OX is there, which is between the focus and the lens. On a figure, carefully draw the two rays from X and locate the position of image and measure the height of the image, which is IY. So first, when we draw the parallel light ray, the parallel light ray should pass through the focus. One through the center of the lens will pass straight. So means these two light rays will never intersect or meet. So when we look, our brain create, like our imagination is there. So when we produce the two light rays backward, the position where these two light rays will intersect, that is the position where the image will form. And it will be a virtual image. It will be upright. Then you have to just measure the distance, the height of this image using your ruler. You will just measure the height. So when object is between the focus and the lens, it will always form a virtual image. State two reasons why the image is virtual. So why the image is virtual? Number one, that the object is between the focus and the lens. That is one thing. And the rays will not meet by themselves after the refraction. So when the object is between the focus and the lens, and the two rays will not intersect. will not meet or intersect by themselves. That's why. Yes, you can mention the image cannot be seen or taken on the screen, form on the screen. That also you can say. So reasons why the image is virtual, that object is between the focus and the lens, because whenever object is placed anywhere, and whenever object is placed between the focus and the lens, the image will always be virtual image. Like it cannot be seen on the screen. And why the image is virtual? Because the light rays from the object will never meet or intersect by themselves. Like when we draw the light rays from the tip of object, it passes through the focus, one through the center will pass straight. So they will not meet by themselves. And you have to measure this height, the distance from I to Y along the principal axis to the center of the lens. So you have to measure this distance, because you measure a distance from IY along the principal axis to the center of the lens. So when it will form, parallel light ray passes through focus, one through the center of the lens will pass straight. So when we produce these two light rays backward, when we produce these two light rays backward, the image we are saying that IY. And the question is, we have to measure a distance between the image and the center of the lens. So you have to measure this distance using your scale. Moving on to question 3, figure 6.1 is a full scale diagram showing a converging lens. The two principal focuses are there, f1 and f2, and on object OP. So again, the object is there between the lens and the focus. So the image is definitely, it will be a virtual image. So first we draw a parallel light ray from tip of the object. It should pass through the focus. One through the center of the lens will pass straight. Again, these two light rays will not meet or intersect, so we produce it backward. So when we produce them backward, the point where the two light rays will meet or intersect, that is the position of the image. And on a figure, draw rays, that is done, and measure the length of the image. Means you have to measure this length of this image. Label the image as IJ. So this is IJ, and label the length of this image. So you just have to measure the height of this. And the three description of the image, because it's an image formed by the convex lens as a magnifying glass, so it is magnified. It is same way up as an object, like upright you can also say, and it is virtual. These are the three characteristics of the image which is formed by a convex lens. Then figure 6.2 shows three rays of a green light passing through the glass. Three rays of a red light approaches the glass, the same path. On a figure, draw the path of red lights. So if these are the green lights, yeah, it will show less bending. We have violet, indigo, blue, green, yellow, orange, and red. Red is having the shortest frequency and the violet is having the highest frequency. The one which is having a higher frequency will bend more, and the one which is having a shorter frequency will show a smaller change in speed or bend less. So if this is a green light, we want to show a red In air, it will be same, but the moment it enter the prism, it will bend less compared to green. And this will be same thing. This is a green light. So compared to green, it will bend less. And one which is passing through the center will pass straight. It won't make, why? Because it is passing along the normal, so that won't change. Only thing what happened, bending of a red is less than green, so it will show a small deviation. But one which is passing through the along the normal won't change the direction, it will only change the speed. Is it clear, this diagram? Yeah, if it is a violet or a purple, it will show a greater deviation. So what if in the question they say complete the path for a violet, then it will show a greater deviation. And but one is just which is passing along the normal won't deviate, it only change the speed, but it does not change the direction. So violet bends the most and red bends the least. So this was a pop quiz.